then we're going to work with linear inequalities in two variables. So we're going to graph linear inequalities on a coordinate plane. And then it also says solve problems using linear inequalities, but we're going to do that tomorrow. So tomorrow we're having a quiz over lessons 2.1 to 2.5. And then afterwards we're going to work with the problems involving linear inequalities. So today we're just going to work on graphing, okay? Making sure that we get the graphs correct. So linear functions form the basis of linear inequalities. Right? The linear inequality just means instead of an equal sign, right, we're going to have an inequality sign, so less than or greater than or less than or equal to or greater than or equal to. And instead of that, our line just being a regular line, it's now going to become what's called a boundary line then. Right? And so our answer is either going to be above our boundary line or below our boundary line. Okay? Some of you might look at it and say, okay, it's left of it or right of it. But basically it's just a boundary line. So here's an example. All right? They've got y equals 2x minus 4 is this red line here on this graph. Okay? The area that's shaded blue is where y is greater than 2x minus 4. And the area that's shaded kind of yellowish or green, okay, that is where it's less than 2x minus 4. Okay? The one thing that will always happen, and we'll talk about how to check these to make sure you're shading in the right area, is that if it's greater than, it'll always be above, right? And less than will always be below, okay, your boundary line. Now the boundary line can be solid or it could be dotted, right? If the boundary line is solid, then that means you have it's either greater than or equal to or less than or equal to that you're working with. If the boundary line is dotted, then that means it's either greater than or less than. Because if it's just greater than or less than, it does not include the line for my possible solution. And so what happens, instead of there just being one solution in this case, there is an infinite number of solutions to the problem. Okay? Because we're talking about a whole region of possible answers instead of just what's on the line itself. Right? So let's look at graphing linear inequalities then. So our main part of this is the same as what we're doing with just graphing lines. Okay? The difference is that you have to pay attention to here and here. Okay? What does that say? If it's not equal to, then we've got greater than or equal to, less than or equal to. Then it depends on whether we're going to have a solid line or a dotted line. So we're going to graph these just like we would any other time we've graphed lines. It's just now it determines whether it's going to be a dotted or solid, and then we're going to shade. Right? So since this says just greater than, our line here is going to be a dotted or a dashed line. Okay? And over here, this one for letter B, since it's less than or equal to, then that's going to be our normal solid line when we actually graph it. Okay? So, graphing these. Right, so we've got, so when I graph it, I'm really going to graph y equals negative 1/3 x plus 2. So my y-intercept is 2, so I put a dot on 2. My slope is negative 1/3, so from there I'm going to go down 1 and to the right 3. So remember when we're graphing lines, all right, when we do the slope, we start at the y-intercept. When we do the slope, we either go up or down, all right, depending on whether it's positive or negative, but we always go to the right. Now, this is going to be a dashed line that goes through here then. Okay? So when I draw this dashed line, right, or dotted line that goes through the graph. So instead of it being a solid line, because it just says greater than, we're going to make a dashed line. And then we're going to shade. And so this says that it's greater than 1/3 x plus 2, so we're going to shade the area above that line. And so my solution isn't just the line itself, it's an infinite number of possible answers. So there is one way to check to make sure that you're shading the right area also. And when I check to make sure I'm shading the right area, I have one specific point that if I can use it, I want to use it. What point would that be? What's the easiest point to work with on the graph? Where at, Chase? Okay, 0 at the origin. Okay, I want to check this point. Okay, so I'm going to put 0 in for x and 0 in for y and see if it's a true statement. So we check, is 0 greater than negative 1/3 times 0 plus 2? All right, so is 0 greater than, all right, so we have negative 1/3 times 0 is 0. Is 0 greater than 2? Is that a true statement? No, okay. Since that's a false statement, then that point should not be in my shaded area. Okay? If it was a true statement, it'd be inside my shaded area. If it's a false statement, then it won't be. So I know I shaded this correctly because of, all right, because 0, 0 is not, the origin is not in there. Okay. So whenever you can check, you want to check with the origin. All right, letter B. Y is less than or equal to negative 1. So is this a horizontal line or a vertical line? Is y equals horizontal or vertical? Okay, horizontal. So, and it says it's less than or equal to, so I'm going to have a solid line. At negative 1. Y equals negative 1. Solid line there. And I'm going to shade, it says less than or equal to. So I'm going to shade below that line then. Okay, so let's use intercepts to graph now. All right, so you can do it either way. All right, have it in slope-intercept form and graph, or use intercepts and graph to create that boundary line. Okay. Now the thing is, when we're working with intercepts, and this is where it actually becomes a little bit trickier with the graphing, as far as the shading part, where you really do need to check the point. But so we need to find our intercepts. And when we find the intercepts, we're assuming, for the purpose of finding the intercepts, that it just equals. All right? We're going to ignore the inequality while we find the intercepts. All right? So the x-intercept, all right, remember we're going to take and let y equal 0 to find the x-intercept. So since 4 times 0 is 0, we can just divide by 3. So our x-intercept is equal to 12 divided by 3 is 4. Turn that off. Our y-intercept, we're letting x equal 0. So our y-intercept 3. Okay. So we'll make our graph, mark the x-intercept at 4, the y-intercept at 3. Now, in this case, it is less than or equal to, so we know we have a solid line. So the question is which side do we shade? And here's where the origin really comes in handy. We really want to check the origin to see if it's true or false there. So if we put 0 in for x and 0 in for y is 0, right? Nice thing about that is 0 plus 0 is 0. Is that less than or equal to 12? Right? Right? And that is a true statement, so we're going to shade the area below the line. So we find the intercepts, graph them, determine whether it's a dotted line or solid line, and then we're going to check the origin to see if it works. Okay, if it's true, we're going to shade the side that the origin is on. If it's false, we'll shade the other side. If the origin is a point on the line, then you just need to choose another point. Okay, 0, 1, 1, 0, something easy like those. All right. Letter B, we're going to find the inequality. So they gave us a graph, and we're going to find the equation of that line then, or find the inequality. So we need to find the y-intercept and the slope. All right, that's the first two things we need to do. All right, they give us the line. We need to find the y-intercept and the slope. All right, so here's my y-intercept. All right, crosses the y-axis at positive 3. So my y-intercept is 3. Slope, I can go from here. All right, here the graph crosses perfectly at a point there. So my slope then is going to be up 2 and over 1. So my slope is just positive 2. All right. So we got two things to work on then. All right. It's a dotted line. So that means that we either have less than or greater than. Okay. And since it's shaded above, all right, then that means it has to be greater than. All right? If it's shaded below the line, it's less than. If it's shaded above the line, okay, it's greater than. So we have y is greater than, okay, so we're going to put this in y equals mx plus b form. We're just going to have the inequality here instead of the equal sign. So y is greater than our slope times x plus the y-intercept. So just like finding the equation of any line, we find the slope, find the y-intercept. The difference is now we just have to determine whether it's less than or greater than, or less than or equal to, or greater than or equal to. All right. So depending on whether it's dotted or solid. All right, so you go ahead and graph this one. Okay. Oops. Here we go. All right. You can also graph linear inequalities on your calculator. All right. We're not going to spend any time working on that, though. I think you can actually change the shading on the calculator to shade above or below. But the thing about that is that you have to have it in slope-intercept form. Okay. If it's not in slope-intercept form, it doesn't work. So we are going to solve and graph here, but now it's a little bit more complicated, right? Now we've got to do a little bit of work before we're able to graph. And I'm going to give you the option, okay? If you want to do these in slope-intercept form, that's fine. If you want to do it with the intercepts, that's fine, okay? To at least be able to check yourself on the graphing, right? So how you graph it is up to you, but the first thing it does say is to solve it for y, all right? So we want to solve for y first of all, so that means that we're going to get it in slope-intercept form, and then we'll graph it. Now, like I said, is that in these cases with these problems, that it is possible to get it in the standard form so that you could just find the intercepts if you wanted to and graph according to the intercepts. Right? So either way. Right? So we've got 3/4 times 8x minus 2y greater than 6. So what's my first step going to be here to solve for y? Ellie, what do we want to do first?
Distribute the top.
Okay, so we can distribute the 3/4. All right, that's one of the things we can do. All right, that's one option. All right, what's another option? There's two options here. That's the first one. What's another one? The other one, Zoe. Okay, yep. The other option is to get rid of the 3/4. Okay, which actually I like that option better because then I just leave this intact. So I'm going to multiply both sides by 4/3 in this case to get rid of that one on that side. So we have 8x minus 2y is greater than, let's see, 6 times 4 is 24, divided by 3 is 8. Right? So at this point in time, you could do the graphing, all right, because we now have it to where I could just find the intercepts, graph them, draw my line. All right, but it says solve for y, so we're going to solve for y. All right? So we subtract 8x. So we get negative 2y is greater than negative 8x plus 8. And then we divide by negative 2. All right, so where's my caution here then? We have an inequality. We're dividing by a negative, which means we have to change the direction of our inequality sign. All right, so instead of greater than, we change it to less than, so y is less than 4x minus 4. Okay. Right. Graph it. Y-intercept is at negative 4. Slope is 4, so we go up 4 over 1. Okay. Those are intercepts anyways. Okay. And we have a dotted line. And once again, we've got to check our shading. So when you check for your shading, we have to go back to the original. All right? Now, I know because this says less than that I'm going to shade below the line. All right? I know it's going down here. All right? That's below the line. All right? But being the good student I am, I'm going to check the origin to make sure it's a true statement there. So when I put 0 in for x, I get 0. Put 0 in for y, I get 0. Multiply 0 by 3/4 and I get 0. Okay? So is 0 greater than 6? No, it's not. So my shading is below the line, okay, the other side of there, so I did it right. Okay? All right. So these, solve for y, all right, and then we shade them. All right. So you're good on the graphing. We've done this before, solve for y, got it in slope-intercept form. Okay? Just the key is here, since we're working with an inequality, if you multiply or divide by a negative, you got to make sure you change the direction of the inequality sign. And that's where graphing using the intercepts, or at least checking the origin, make sure it works, will help you.